You can use MANORAA to observe the binding affinity. So in this case, we use trimethoprim small string, and we will end up with a lot of trimethoxybenzyl analogs. We only want the exact match of trimethoprim. So we want the structure with this trimethoxybenzyl and this ring. And in order to superpose the structure we want, it's up to this carbon here and this ring. So we use these atoms. And then we use binding distance correlation. And this function, you can have the equation, and you can see that leucine 5 affects the binding affinity. And we have proven these residues in wet lab that it can increase the binding affinity by 1/4 if it was mutated to valine, and this distance is expanded to valine because valine have one carbon less. And we can do drug design, and again you can see that we can extract the distance that affects the binding affinity, and you can see this distance with leucine 5 again at this point, which affects the binding affinity. So leucine 5, this one B9, log Ki equals to some constant plus coefficient and B9, and this one B9, this one B9, and we mutated this B9. So it's become leucine 5 mutated to V. And we can also see the protein ligand interaction. Let's say if we want to observe this nitrogen, we can choose protein ligand interaction. And you can see that this distance, these interactions in Pneumocystis carinii have 4 hydrogen bonds. So this one is bound quite tightly. And for this one, which have only 2 hydrogen bonds, bind looser than the other one with 4 hydrogen bonds, for example. So in this way, we can improve the binding affinity by observe the way to strengthen the interaction inside the pockets to improve the binding affinity of trimethoprim and for protein engineering. So we can find the residues and we mutate it to imitate the one with tighter or loosely bound residues. And we can also do some conservation interaction by doing this carbon superposition here. And we can see the conservation sites by superposing these residues here. You can see that there is a lot of things we can do, and we can also see the binding. Let's say this one, it said this protein is in folate biosynthesis, and the protein was highlighted in this node 1.5.1.3 in this folate biosynthesis. So this one stands for easy number of dihydrofolate reductase. We can also see antifolate resistance pathways, and then we can see that how the DHFR was mutated